Hey everyone, welcome back to this channel. In our last two sessions, we understood how to identify an outlier, how to remove those outliers, or how to mitigate the effect of outliers using log transformation. Okay, now in this session, we are going to understand how to use Z-score to identify and remove outliers. First of all, tell me what is an outlier? Outlier means those data points which are significantly far from the mean value. Now, what is a Z score? Z score is a measure, a standard score. It measures how many standard deviation a data point is from the mean of the data set. Okay, so it calculates the distance of the data points from the mean in terms of standard deviation. Fine. How to calculate? Z equal to x minus mean by standard deviation. Mean means mean of the data set. Standard deviation means standard deviation of the data set. And x is any particular data point. Okay. So Z-score tells you how far a particular point is from the mean data. If that is positive, that means the data point is above the mean. If it is negative, the data point is below the mean. Fine. Now after you calculate the Z-score, you have to create a threshold value. Typically it is 3.0, but you can adjust as per your specific needs. We will see that. Okay. Now after you calculate your Z score, set a threshold, then you can flag the outliers. You can identify those data points which are outliers, which are not as usual. Now you can simply remove them. Okay. Now let's do it. First I want import numpy. Now from scipy dot stats import get score. If you want, you can calculate by yourself also. Simple formula, but it is already written, so we will just import this. Okay. Now create a data set. Data 9 equals to np dot array, and within this we can write 10, 15, 20, 25, 30, 29, 40, 25. Okay. Suddenly I insert a point 5000. Then again I give 15, 17. Okay. So you can easily say this one is the outlier. You can check by describe function or by interquartile range also. But here our main objective is to learn Z score. Okay. So first we will calculate the Z score. So Z score equal to Z score of data 9. Exactly. Now run it. What has happened? Oh, I'm so sorry. Now fine. Now let's see the Z scores. Distances from the mean minus 0.32. Almost same, but this one, see, 5000, 3.16. You can see that it is far different from others. Okay, so you can easily check here that there are outliers. Anyway, you may have a weak data set. Here we are working with small data set, that's why we can easily identify. Anyway, now I will give a capping. So I will set a threshold value. Okay, so let's write outliers threshold equals to 3. Typically it's 3, 3.0. Now let's find those data points which are greater than 3.0. They will be outliers. So I can write np.abs. Abs is a function. You can say absolute function. It calculates the absolute value. So z scores greater than outliers threshold. Exactly. Only those values which are greater than 3.0. This is false. All of them will be false. Only this one will be true. Fine. So I want only these value as an outliers. So I can simply write it outliers. Fine. Let's print it again. Okay. Okay. Now let's visualize this. I can write plt dot scatter plot. You remember shows the relationship between data points. Now I have to write a range because I want to generate a range of numbers for x coordinates. So length of data, oh sorry, data 9. Okay. This is the X point. What is the Y point? Y point is data, data 9. Okay, fine. So X point, X coordinates we are generating, and Y coordinates are the data 9. Now let's see. See here. This one is outlier. Okay. X coordinate, Y point. The outlier is almost near 5,000. Oh, no, it's exactly 5,000. So it's the outlier. You can visualize this way. Fine. Now I want to simply remove them. That means I want only these data points. So I can simply write filtered data equals to data 9 outliers. That means remove the outliers and keep all the values. This does exactly opposite. Okay. Now let's run this. Fine. Now let's print this. See, there is no 5,000. Okay, so you have done your job. Now let's do one more thing. I add 7,000. Now see, both of them are outliers. So both of them must be removed. Let's see what happens. Let me run all these values. And you can see two outliers significantly different from others. So here you can see, no, these are not removed. Why is that so? You try to think. If you can't, no problem, I will tell you. Check here. This is the value of 5,000, 1.75. This is the value of 2.64. So these are the distances. But threshold is 3.0. So they can match the criteria. So that is why it's simply not removed. So now if you want, you can change the threshold value. You can give 2. If you want to remove 7,000 only, you can give 1 or 1.6. Any value below 1.75. So if I give 1.5. Now check. Now if I run this, then 5,000, 7,000, both of them will be deleted. Okay. Say both of them deleted. Clear? So typically it is 3.0, but if you want, you can change. So this is the way you can use Z-score and remove your outliers. Okay, so you can remove by IQR, you can remove by Z-score also. Okay, now I will give you a homework. Tell me when it is better to use Z-score and when it is better to use interquartile range. Okay, let me know this by comment. If you don't know and if you want to know, then also let me know. I will explain you in my next class. Okay, so meet in our next class. Till then, bye. Happy learning.